Yes, can you hear me? आवाज आ रहा है क्या?
Yes, sir.
Okay. Only 4 participants have joined. We will start. Good morning to all. Myself, Shoaib Pirzadeh, Assistant Professor, Department of Chemistry, Milia Art Science and Management Science College, B. We are discussing on topic thermodynamic second. In the last period, we have discussed about that is Gibbs and Helmholtz free energy. So in the last period, we have studied in detail about the Helmholtz free energy. Now, today we discuss about that is Gibbs free energy. Gibbs free energy. Now, Gibbs free energy is denoted by, first of all, that is the capital G. Remember that. And Helmholtz free energy. Helmholtz free energy is denoted by, yesterday we have seen. हेल्महोल्ट्ज फ्री एनर्जी को किससे डिनोट करते हैं? कल देखा है हमने. एस टेल मी. हेल्महोल्ट्ज फ्री एनर्जी इज डिनोटेड कैपिटल ए.
Capital A.
So in the last period we have seen Helmholtz free energy is denoted by capital A, and remember that Gibbs free energy is denoted by capital G. Now we see the definition of that is Gibbs free energy. So Gibbs free energy can be defined as, that is capital G is equal to H minus Ts. This is the definition of Gibbs free energy. That is G is equal to, G is the Gibbs free energy, H is the enthalpy, T is absolute temperature, and S is the entropy. S is the entropy. We call this as equation number 1. Okay, so this is the equation number 1. So Gibbs free energy can be defined as G is equal to H minus Ts, where G is Gibbs free energy, H is enthalpy, T is absolute temperature, and S is the entropy. Now, this Gibbs free energy is a state function. Gibbs free energy is a state function, that is the quantity which depends upon initial and final state of the system is called, that is the state function. So previously we have seen that is Helmholtz free energy is also a state function. So here Gibbs free energy is also a state function. So it is a state function and depends on initial and final state of the system. That is the quantity which depends upon initial and final state of the system is called as, that is the state function. So Gibbs free energy is a state function. So for initial state we can write G1 is equal to H1 minus T1 is S1. This is the equation of Gibbs free energy in, that is initial state. In initial state we have taken, that is the suffix 1. So G1 is equal to H1 minus T1 S1, where G1 is the Gibbs free energy in initial state, H1 enthalpy in initial state, T1 temperature in initial state, and S1 that is entropy in initial state. Now similarly for final state we can write, now final state we can write G2 is equal to H2 minus T2S2. So for final state, Gibbs free energy can be written as G2 is equal to H2 minus T2S2. Where what is G2? G2 is the Gibbs free energy in final state. H2 enthalpy in final state. T2 temperature in final state, and S2 entropy in final state. So this is that is Gibbs free energy. Gibbs free energy is given by G is equal to H minus Ts, gives free energy is denoted by capital G, and G is equal to H minus Ts. H is enthalpy, T is temperature, and S is, that is the entropy. And this gives free energy is a state function. We have written the gives free energy in initial state by equation number 2, and gives free energy by equation, that is in final state, by equation number 3. Now next, we calculate here change in gives free energy, that is delta G. So therefore, change in gives free energy is given as delta G is equal to G2 minus G1. G2 minus G1. Now put the values of from equation 2 and 3. See, this is the equation 2 and 3, and we have calculated here the values. That is G1. This is the value of G1. G1 is H1 minus T1 S1, and G2 is equal to H2 minus T2 S2. Now put these values, that is from equation number 2 and 3 in equation number, that is in this equation, that is delta G. Therefore delta G is equal to G2 minus G1. Therefore delta G is equal to, what is the value of G2 from equation number 3, that is H2 minus T2 S2. This value from equation 3, equation 3 में दी हुई है G2 की वैल्यू, तो वो G2 की वैल्यू हमने यहाँ पर रखे हैं. So H2 minus T2 S2 minus G1. G1 की वैल्यू इक्वेशन 2 में दी हुई है, it is H1 minus T1 S1. So this is the delta G. Therefore delta G is equal to, now take the H2 and H1 together. This is H2, this is H2. Now this multiply this minus by this H1, this minus H1, and we have written here, that is this is H2 as it is. इस ये माइनस से H1 को मल्टीप्लाई करना है, और यहाँ तो क्या होगा माइनस H1. वी हैव रिटन फर्स्ट हियर माइनस H1. नाउ which quantity remains again? This minus T2S2 we have written here, that is minus T2S2, and this minus and this minus, it gets plus, so we have written plus T1S1. Understand? That is we have taken, that is H2 minus H1. This H2, this minus से मल्टीप्लाई करेंगे H1 को, तो माइनस H1 होगा. नाउ दिस माइनस T2S2, और ये माइनस और माइनस क्या होगा, प्लस होगा, प्लस T1S1. Therefore delta G is equal to, now see, change H2 minus H1. Instead of this, what we can write, that is the delta H. So this H2 minus H1 की जगह हम change in enthalpy लिख सकते हैं. So instead of this H2 minus H1, we can write delta H is equal minus this T2S2 plus T1S1. So this is the change in Gibbs free energy. Now for isothermal process, isothermal process में क्या होता है? A process in which temperature of the system remains constant is called isothermal process. यानी temperature constant होता है. So we can, for isothermal process, we can write T2 is equal to T1 is equal to T. ने क्या करना है? ऊपर के इक्वेशन में, दिस इक्वेशन में क्या करना है आपको? जहां पर T2 है और T1 है, वहां पर क्या लेंगे आप? T लेंगे. तो देन अब वो इक्वेशन becomes, therefore delta G is equal to delta H minus this T2 है, T2 के जगह आप क्या लेंगे? T लेंगे, because process is isothermal, that is temperature remains constant. So we have taken here T, TS2 plus T1 के जगह पे क्या लेंगे आप? T लेंगे, TS1. Therefore that is delta G is equal to delta H minus TS2 plus TS1. अब देखिए इसमें कॉमन क्या है? डेल्टा H minus TS2 plus TS1. इसमें T कॉमन है. Here also T and here also so T. So we can take, that is a TS minus TS, that is the common in the next step. So that is therefore delta G is equal to delta H minus T हमने कॉमन निकाला. देखिए this is from this minus T कॉमन निकाल, तो ब्रैकेट में क्या रहेगा? ये S2 minus S1. S2 minus S1. We have taken, that is minus TS common. तो minus T common लेंगे तो ब्रैकेट में क्या रहेगा? S2 minus S1. So we have written in the next step, that is therefore delta G is equal to delta H minus T into S2 minus S1. Now therefore delta G is equal to delta H minus T into, now this S2 minus S1, S2 minus S1 इसके लिए क्या लिख सकते हैं आप, that is we can write delta S. So instead of this we can write delta, change in entropy, change in entropy. Therefore that is delta G is equal to delta H minus T into delta S. This is the alternatively Gibbs free energy and can also be therefore delta G is equal to delta H minus T into delta S. Now alternatively Gibbs free energy can also be defined as, so this is the one definition of Gibbs free energy. Now alternative second definition Gibbs free energy can also be defined as G is equal to A plus PV. G is equal to A plus PV, where G is the Gibbs free energy, A is Helmholtz function. ये दूसरी डेफिनेशन है गिब्स फ्री एनर्जी की. पहले डेफिनेशन क्या है, G is equal to H minus Ts we have seen, and we also calculated the change in Gibbs free energy. Now the second definition of Gibbs free energy, that is G is equal to A plus PV, where G is Gibbs free energy, A is Helmholtz function, P is pressure, and V is, that is the volume. Now from equation 4, so see this is the equation number 4, that is delta G is equal to delta H minus T into delta S, but T into delta S is nothing but that is the Q reversible. Yet equation 4 में जो है, equation 4 में T into delta S के जगह हम क्या लिख सकते हैं, that is the Q reversible. So we can write that is instead of this T into delta S as Q reversible. So equation 4 becomes, so from equation 4 देखिए equation 4 क्या है, delta G is equal to delta H minus T into delta S. यहाँ पर Q reversible की जगह क्या है equation 4 में, T into delta S, but Q reversible is equal to T into delta S is equal to Q reversible, यानी T into delta S किसके बराबर है, Q into Q reversible. So we can write that is instead of this T into delta S as Q reversible. Therefore that is a delta G is equal to, now again that is a delta H is equal to delta U plus P into delta V. देखिए in this equation delta G is there and delta H, and here T into delta S is there, but T into delta S is equal to Q reversible. Now again that is delta H is equal to delta U plus P into delta V. Delta H किसके बराबर है, delta U plus P into delta V. Now put again delta G is equal to delta H, but delta H किसके बराबर है, यहाँ पर दिया गया है आपको, that is the delta U P into delta V. So delta G is equal to delta U plus, that is the P into delta V minus Q reversible. Now from this take minus common, minus sign common, then what remains in the bracket, minus into minus Q reversible, minus into Q reversible, क्योंकि हमने this minus we have taken common, so यहाँ पर क्या होगा फिर प्लस रहेगा, so minus into Q reversible. ये प्लस है but here we have taken minus, क्योंकि बाद में क्या होगा, this minus get plus, so plus delta U होगा. Then minus P into delta V, minus P into delta V, because here is the plus, this minus and this minus get plus, so we have taken the minus sign common, delta G is equal to minus in bracket Q reversible minus delta U minus P into delta V. Therefore delta G is equal to minus, now we have seen the, that is Q reversible minus delta U, from first this is nothing but that is the W max from first law of thermodynamics, that is Q reversible minus delta U is nothing but that is the work done, so minus W max minus P into delta V. So this is the Gibbs free energy change. Hence the equation shows that minus delta G represent maximum net energy at constant temperature and pressure available for doing useful work. Hence we can say that that is a minus delta G represent maximum net energy at constant temperature and pressure available for doing useful work. Now the next point is that is so this is about the Gibbs free energy, and that is the Gibbs free energy change. Now free energy criteria for equilibrium and spontaneity. Free energy criteria for equilibrium and spontaneity. Now free energy is a state function which depends upon initial and final state of the system. As we have seen, that is free energy is a state function. State function, that is the quantity which depends upon initial and final state of the system, is called state function. So free energy is a state function which depends on initial and final state of the system. It also depends on temperature and pressure of the system. That is, this Gibbs free energy depends upon temperature and pressure of the system. Absolute value of free energy cannot be determined. The absolute value of free energy we cannot determine, but delta G, that is change in free energy or difference in free energy, we have calculated previously, during a process can be dealt with. Now, in spontaneous processes of constant temperature and volume are characterized by a decrease of Helmholtz free energy. That is, spontaneous processes of constant temperature and volume are characterized by, that is, decrease of Helmholtz free energy. The Helmholtz free energy continues to decrease as long as spontaneous changes occur within the system when the changes cease. So the Helmholtz free energy continue to decrease as long as spontaneous changes occur within the system. When the changes cease, the system is in equilibrium and the Helmholtz free energy has reached a minimum value. Consequently, that is, when the changes cease, the system is in equilibrium and the Helmholtz free energy has reached a minimum value consequently. So we can write that is dA, that is A means here Helmholtz free energy, dA Helmholtz free energy, and it is at T1 and V. So this is T1, here one is in suffix, remember that T1, it is T1, one is थोड़ा सा दूर हो गया है वन से, so it is T1 into V, that is temperature and volume. So change in Helmholtz free energy at, that is constant, T1 and V. T1 is temperature and V means, that is the volume, equal to 0. This is equation number 1. Now the equation applies when only PV work, that is pressure volume work, is considered. Similarly, for constant T and P we can write, for constant T and P, that is we can write dG, that is we can take here Gibbs free energy, change in Gibbs free energy, dG is equal dG at T1P. T1P means, T1 is constant temperature and P means pressure. Here also, that is one is in the suffix T1, T1 is there. So T1 and that is equal to 0. Okay. Now again we have to take the cases. If delta G is negative, if the value of delta G is negative, as previously we have studied, if the value of delta G is negative, the reaction will proceed from left to right. यानी अगर डेल्टा जी की वैल्यू नेगेटिव होती है तो क्या होगा, रिएक्शन कहाँ होगी, रिएक्शन विल प्रोसीड फ्रॉम लेफ्ट टू राइट, reaction will proceed from left to right and energy is emitted on reaction. Remember that is very important, that is when the value of delta G is negative, the reaction will proceed from left to right and energy is emitted on reaction and hence reaction proceed spontaneously. Reaction proceed spontaneously. देखिए reaction कब spontaneous होता है, if the delta G is negative, reaction will proceed from left to right. देखिए जब डेल्टा जी की वैल्यू नेगेटिव होगी, रिएक्शन will proceed from left to right and energy is emitted energy is emitted, hence reaction is spontaneous. Next, if delta G is positive, अगर delta G positive है, if delta G is positive, reaction will proceed from left to right and energy is absorbed. Remember that. नेगेटिव है तो एनर्जी इमिटेड हो रही है, और इफ डेल्टा जी इज पॉजिटिव रिएक्शन विल प्रोसीड फ्रॉम लेफ्ट टू राइट एंड एनर्जी इज एब्सॉर्ब, एनर्जी एब्सॉर्ब होगी, द रिएक्शन इज नॉन स्पॉन्टेनियस. रिमेंबर दैट व्हेन रिएक्शन डेल्टा जी इज नेगेटिव देन दैट इज एनर्जी इज इमिटेड and reaction is spontaneous, and if the value of delta G is positive, the reaction will proceed from left to right, energy is absorbed. Remember that energy is absorbed and reaction is, that is non-spontaneous. Reaction is non-spontaneous. If delta G is 0, it indicate equilibrium state. It indicate the equilibrium state. Remember that. That is, if delta G is negative, the reaction will proceed from left to right, energy is emitted and reaction is spontaneous. If delta G is positive, reaction will proceed from left to right, energy is absorbed and reaction is non-spontaneous. And lastly, if delta G is 0, अब तीसरी कंडीशन डेल्टा G की वैल्यू 0 है, इट इंडिकेट इक्विलिब्रियम स्टेट. रिएक्शन क्या होगी, इक्विलिब्रियम स्टेट में होगी, एंड डेल्टा जी इज रिलेटेड विथ एंड बाय एन इक्वेशन. डेल्टा जी इन इक्वेशन से रिलेटेड, वी हैव ऑलरेडी सीन दैट इक्वेशन, दैट इज डेल्टा जी इज इक्वल टू डेल्टा एच माइनस टी इनटू डेल्टा एच. वी ऑब्टेन दैट इक्वेशन आल्सो. नाउ at constant pressure for exothermic reaction, or for exothermic reaction, delta G is negative. That is, at constant pressure for exothermic, delta G is negative and hence is negative. That is, therefore reaction is spontaneous. That is, at constant pressure for exothermic reaction, delta G is negative and hence is negative, therefore reaction is spontaneous. Now a positive value of delta H, a positive value of delta H, that is endothermic reaction. What is exothermic reaction? A reaction, we have seen exothermic reaction emit हो रही है, a reaction in which heat is evolved, और positive जब है तो क्या होगा, energy absorb होगी, that is endothermic reaction. A reaction in which heat is evolved is called exothermic reaction. जिस reaction में heat evolve होती है उसे हम क्या कहेंगे, exothermic reaction. And a reaction in which heat is absorbed, it is called endothermic reaction. So a positive value of delta H, a positive value of delta H, that is endothermic reaction, means increase in free energy, and hence the reaction is non-spontaneous. In exothermic reaction में क्या होगा, reaction spontaneous होती है, delta G negative होगा, while that is in endothermic reaction the value of delta G is positive and reaction is, that is non-spontaneous. Since T is always positive, because temperature is always positive, a decrease in entropy would make a delta G positive and hence that is the reaction would not be spontaneous. So reaction क्या होगी, spontaneous नहीं होगी. That is, since T is always positive, a decrease in entropy would make a delta G positive and hence the reaction would not be spontaneous. So this is about the, that is free energy criteria for spontaneous and for equilibrium and spontaneity. So this is about the, that is a criteria for free energy criteria for spontaneity, equilibrium and spontaneity. It is the theoretical part, so you remember. Now question may be asked for 10 marks, that is explain free energy criteria for equilibrium and spontaneity. Or sometime that is a short note may be asked, write a short note on Helmholtz free energy for 5 marks, or write a short note on Gibbs free energy So we have to write that is the, if we gives free energy is asked, so you write the definition and change in gives free energy and these equations. Understand? So this is about the Gibbs free energy, Helmholtz free energy, and free energy criteria for equilibrium and spontaneity. Understand? Only one bit from this topic is remains. In the next period, we see that bit. If you have any difficulty, you please ask. नेक्स्ट पीरियड में हमारा ये टॉपिक कंप्लीट हो जाएगा. ओनली वन पीरियड रिमेन्स. एक पीरियड में टॉपिक होगा, देन इन द नेक्स्ट दैट इज द थर्ड एंड लास्ट टॉपिक. ये सेकंड टॉपिक. Okay, we will stop here.